Okay, section two. Section two, we're going to focus more on um, logistic function, but also both exponential and logistic function modeling. Modeling means that kind of like what we were doing in section one with writing an equation, but this time it's more of a word problem. All right, let's look at this function. So we're going to kind of dissect this a little bit. This is called a logistic function, and this is new this year, so kind of take a minute to familiarize yourself with how it looks. You can see here, there's an exponential function here, a times b to the x. The difference now is that it's in the denominator with a +1 next to it, and then there is a numerator, c with this. So let's just kind of look at a logistic function. Most logistic functions look something like this. And I say most because sometimes it will go the other way, but that shape is the same. So in a logistic function, what is key is that there are two horizontal asymptotes. So I know some of you were wondering before, is it possible to have two horizontal asymptotes? Yes, it is. In this kind of function, you have one asymptote at the bottom and one asymptote at the top. And the question is, what is the can you figure out what the asymptotes are? Well, if the logistic function is in this form meaning you have a number on the top, and then the key here is you have a 1 and then a plus exponential function. If it is in this form, then the two asymptotes are y equals 0 and then y equals c. And then I'll show you how you can actually figure that out on your own without actually just memorizing this. But either way, this logistic function pretty much always looks like this. It always definitely, for sure, has two asymptotes, one on the bottom and then one on the top. And that top is called, this C is called a limit to growth. Why is it called a limit to growth? So if you kind of think about exponential function, it just expands forever, right? It just the higher the x is, the bigger y is, and so it can kind of do that forever. But logistic function, however, there's a limit to growth right here. So you cannot expand forever. There is a cap. After this number, it will still grow, but it will just try to get to C, but then it will actually never be C because there's some kind of cap. So let's look at a word problem and you can kind of see this a little bit better. Find the equation for the logistic function that satisfies initial value is 10, limit to growth, that's the cap, is 40, and then it also passes through this point 120. Now, kind of same thing as before. When you're trying to write an equation, you always ask yourself, what variables do I really need to solve? What do I really need to create this equation? If you look at this equation, this logistic function, you have A, B, and C. So there are three things you need to figure out. And again, when you think about Algebra 2, that very basic idea of solving equations, if you have three variables, then you need three facts. So three independent equations in order to solve for three variables. And therefore, that is why they give you three pieces of information for you to find A, B, and C. All right, let's see how we can use this information. First, initial value is 10. Initial value means when x is 0, this function is 10. So when x is 0, this function is 10. Make sure you write it this way. Don't assume C is 10 or don't assume A is 10 or B is 10. Just when you put in x, you get 10 is really what it's saying. Limit to growth. Limit to growth means C is 40. So this is the cap. It cannot go higher than 40. Passes through this point 120. That means f of 1 is 20. So every time they give you a point, it's really just f of something equals something. All right, these three pieces of information we're going to use to create this equation. All right, first thing is we already know what C is, so that's nice. We can just put that in the equation. And since this one has a nice number 0, I'm going to start with that. So it tells me that y is 10 when x is 0. So 40 goes into the C part, plus 1 plus a times b we don't know to the 0. All right, b to the 0 is 1. So 10 equals 40 over 1 plus a. Hopefully this is an easy thing for you to solve. Remember, you're just going to cross multiply and solve. So 10 times 1 plus a equals 40. And this is where you want to solve smart and not longer. So you can distribute the 10 if you want to, but it is not the fastest way. The fastest way is to divide both sides by 10. So then you just get 1 plus a equals 4, and therefore a is 3. So this is the fastest way to solve. All right, we got C, we got A, now we're going to get B. B requires the last piece of information, so f of 1 is 20. So we're going to put 20 in. 40 over 1 plus A is 3. B we don't know, to the first. B to the first is just B. So this is just 1 plus 3b in the denominator. So again, we're going to multiply both sides or cross multiply. And again, this one is easy enough that you don't want to distribute the 20. You just want to divide by 20. So 1 plus 3b is 2. Subtract 1 on both sides. Oops. 3b is 1, so b is equal to 1/3. All right, let's go ahead and put all that back together. So f of x is equal to, what this is, 40 over 1 plus 3 times 1/3 to the x. Again, don't multiply 3 and 1/3 together. They're not the same thing. You cannot multiply that with a function. Okay, so this is the function. Let's have you try one. Find the equation for the, this practice one. So go ahead and try this one. Pause the video and come back and check your answer. All right, go ahead and check your answer. All right, now we're going to look at a different kind of question. This question says, determine whether the exponential function is a growth or decay function. Then determine the percent growth, rate of growth or decay. All right, to figure out whether it is a growth or decay, we just look at a base. So this base is more than 1, so this is a growth function. The question next is, how much are you growing by? This is actually pretty easy because if you kind of think about it, if you hold a consistent rate over time, like as if you're basically not growing and not decaying, then you must be operating at the same as before, right? Same as before. You keep going at the same rate. So that just means that you're at 100%, like 100% meaning you're exactly the same as before. If you want to grow, then you have to go higher than 100%. So if your base is like 120%, that means you're growing by 20%. If your base is, let's say, 80%, that means you're losing by 20%, right? So 100% is the base, like as in like you're not changing at all. So if you want to figure out whether it's, how much you're growing or how much you're decaying, then you kind of compare it to 100%. So base is the same as, is equal to 1. This 1 just means 100%. And then plus R. R is the rate. So is it adding on a number or is it subtracting a number? That tells you whether you're growing or not. So for example, this one, the base is 1.0064 is equal to 1 plus R. And so if I subtract 1, I can see that it's 0.0064. is the rate. And so if you change that to a percent, remember changing to percent, you move the decimal place over by 2. So this is 0.64%. So the rate is growing by 0.64%. All right, now let's go ahead and have you try. Determine whether it's growing or decaying, and then by what percent. All right, let's look at the answer. So both of them are decaying, and if you look at the calculation, so both of them are going to give you negative numbers, obviously, because it's decaying. Now, when you write the percent decaying, the question now is, do you need to put a negative? The answer is it really doesn't matter very much. If you're telling people that it's decaying, it's just, it's very intuitive that it must be subtracting from 100%. So if you just say it's decaying by 1.42%, everyone knows that you're going to subtract 1.42% from 100. So it's not necessary that you write minus, but if you do, I'm pretty sure that it really doesn't matter. It's just a little redundant. All right, now let's kind of go backwards. So this one says write an exponential function that satisfies the given condition. All right, so we're now back to exponential. So make sure you read the question really carefully. Sometimes they want exponential, sometimes they want logistic. Number one, the initial value is 5, increasing at a rate of 17% per year. Remember, you want to start with your basic function. You are trying to figure out A and B. All right, in this case, initial value is 5. That means if you put 0 into the function, you get 5. So 5 is equal to A times B to the 0. That's gone, so A is 5. For the most part, A is the initial value, so you can just kind of assume A is 5, but remember, this only works for an exponential function. Next, find B. We're increasing at a rate of 17% per year. So remember the equation, base is 100%. And then depending on if you're increasing or decreasing, this one's increasing, so we know we have to add 17%, but remember to change that to a decimal. So 1.17. So the base is 1.17. And you can always double check to see if you did it right or not. If your base is lower than 1 and you read the question again, it says increasing, then you did it wrong. So y is equal to 5 times 1.17 to the x. Okay, I'm going to do one more, and then you're going to do number 3. Initial value is 5, again, decreasing at 0.59% per year. So A is 5. B is 1. It's decreasing, so we're going to subtract. Make sure you change it to decimal before you subtract. So this is actually 0.0059. 1 minus 0.0059. 0.9941. So y equals 5 times 0.9941 to the x. All right, go ahead and try this next one. All right, please check your answer. All right, now let's look at other exponential models. So most things are going to go with the form of a times b to the x, most things. But there are there are times where you're going to see questions where it says it doubles, it doubles every 2 days, or it doubles every minute, or it doubles every 10 seconds. So when that happens, you have this rate that happens at a certain gap or certain interval. Then what you would actually do is you would change this slightly to x over t. T is how often it takes for this doubling or halving to happen. So for example, this question says, um, suppose a culture of 100 bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will be 350,000. Well, this one is going to double every hour, so uh, this is still the basic equation. Okay, so you put in 100 bacteria into a petri dish, and this bacteria is going to double every hour. All right, can we write an equation for that? So we need A and B in order to write an equation. So A means initial value. So the question you ask yourself is, what is the initial value of bacteria? That is 100. Next, base. Um, It tells you that it doubles every hour. So every hour it doubles. So, this at the beginning was 100, the next hour will be 200, the next hour will be 400. So what is the base? The base is 2 because it's basically 200% of whatever it was before. So this is 2. Then the last question is, when will you get 350,000? When will you get 350,000? Well, what is that? Is that X or Y? That is Y. So when will you get 350,000? All right. This requires that you remember how to solve this kind of question from last year. All right, first thing, what should you do? You should divide by 100. So divide by 100 means take off 2 zeros. So 3,500 equals 2 to the x. Now, if you recall from last year, in order to solve this, if 3,500 is a number you can change so that the base is 2, then this is a very easy problem to solve. However, 3,500 is not a number we can change to a base of 2, so we have to try something else. And that is called log. So maybe you're kind of thinking, no, it's log again. Yes, it is log again. So what we want to do is we're trying to get this x, right? We're trying to solve for x. X is in the exponential position, so we need to bring it down. If you recall, what you need to do is you need to put a log on both sides. So log on both sides, it really doesn't matter what log. So this whole chapter, we're also going to go through logs. So there are two kinds of logs that you use most often, log and ln. Log means log base 10. Ln means log base e. So very quick review. Those are functions you can find on the calculator. So if you remember, if you put a log in front of something that has an exponent, one of the rule is you can bring this exponent down. So this becomes natural log 3,500 equals x natural log. You see how I put parentheses around x and natural log 2? That way I know that they're multiplying together, so I can kind of separate my numbers a little bit. Okay, now I'm going to divide by natural log 2. So x is equal to natural log 3,500 over natural log 2. Now what you want to do is use your calculator. Natural log button is on the left-hand side of your graphing calculator towards the bottom. When you type this in the calculator, you're going to type in natural log, and then it automatically creates a parentheses, open parentheses. You put 3,500, but remember you got to close parentheses. If you don't, you're going to divide the next number inside the natural log. So this is not correct. Make sure you close parentheses, and then you're going to divide natural log, and then open parentheses again, and then 2. If it's the last thing you do, then you don't have to close the parentheses. But if you have something you have to type after that, then you do need to close the parentheses. Okay, anyways, the answer is 11.77 about, and this is hour. Okay, let's look at another question. Suppose the half-life of a certain radioactive substance is 20 days and there are 5 grams present initially. Find a time when there will be 1 gram of the substance remaining. So again, this is y equals a times b to the x. Except this one is not just an x, this is x over t. How do you know? Well, this is going to decrease by every 20 days. What's the difference if you don't put t? What's the difference? If you don't put over t, you're basically decreasing at every day or whatever the unit they give you, it's happening every 1 unit. So if you don't, this tells you that every 20 days there's a cycle. You don't reduce by half until you reach 20 days. Right, so every 20 days you have a cycle. So the first time it reduces by half is 20 days. The next time it happens is 40 days. If you don't put that in, then you're assuming it keeps happening every single day because it's just going to, you're not dividing by anything. So you're not reaching a 20-day mark before you have half of the amount left. Anyways, if that is very confusing, ask me in class, I will help you. So this is over t. All right, let's go ahead and put everything we know in here. So initially there are 5 grams. You have a half-life. Half-life means whatever amount you had in the beginning, you decrease by half. So if you have 100 in the beginning, then 20 days later, you have 50. So something like that. So that means the base is 1/2. You're decreasing by 1/2. Every 20 days though, so you're going to divide by 20. So same thing here, predict the time when you will have 1 gram left. So 1 gram. All right, let's go ahead and solve this one. Divide by 5. 1/5 and 1/2 are not things we can change to the same base, so you do need to use log again. So go ahead and solve this question and then come back and check your answer. All right, so hopefully you were able to solve it. So if you kind of do this where you don't actually plug in any numbers until the very end, I think it's a very good practice of just kind of pushing your math a little bit farther. Uh, if you did put numbers in from the very beginning, like if you started using your calculator from the very beginning, it's fine too. Just remember you need to keep as many digits of the number as possible, because if you start rounding early, you're going to have a very different answer from the actual answer. So just be careful of that. So the answer is 46.439 days. Or you can round it to 46 days. All right, last question. This one is for a logistic question. Watauga High School has 120 students. Bob, Carol, Ted, and Alice started a rumor which spread logistically so that S of T equals this model. And this model is the number of students who have heard the rumor by the end of day T. Okay, how many students have heard the rumor by the end of day 0? All right, so let's kind of look at this equation a little bit. S means what? S means students. So this number of students who have heard a rumor is modeled by this, and then remember T means days. Now this is a logistic function, so the question now is I want to kind of dissect it a little bit for you. Why is there 120 on the top in the numerator? In a logistic function, what position does that 1200 represent? That is the cap to growth, right? Why is it 1200? Because there are only 1200 students. So you can only spread to 1200 students. All right, so let's kind of look at this first question. How many students have heard a rumor by the end of day 0? That is S of 0. What is S of 0? Go ahead and figure that out. Should be pretty easy. Okay, the answer is 30. So by the end of day 0, there are 30 students who heard this. How long does it take for 1,000 students to hear the rumor? So this is where it does take a little bit of time to solve. 1,000 students is equal to 1,200 over 1 plus 39 e to the negative 0.9t. All right, let's talk about how to solve this. So what do you think we should do first? Okay, same thing as before, multiply by the denominator. Now what? This is definitely you want to divide by the number in front, not distribute. So 1,200 divided by 1,000, that's 1.2. Now what? Subtract 1. And then what? Divide by 39. All right, now you may want to take a calculator out and do this, but I would strongly suggest that you don't. Just keep it until the very end. The longer you can hold it before you actually put in the calculator, the better the number will turn out at the end, because you don't have to round so much and you don't have to write down all these numbers. All right, next, we got to get this t down from the exponent position. And luckily, this is a base of e. And then if you recall, natural log has a base of e. That means it will just cancel out. And then you actually don't even have a natural log e, because natural log e is just 1. So this is nice. We apply log on both sides, or natural log on both sides, and then we get to here. And the last thing you're going to do is just divide by negative 0.9. All right, now use your calculator. You will get the answer 5.8, 59, which is about 6.